Welcome to this lecture about modeling soil erosion. This is part of the e-learning course on smart agriculture and will explain how you can model soil erosion, particularly through water precipitation in GIS. First, I will explain how soil erosion is linked to climate change, and then we will look at the key base for the model, the universal soil loss equation, USLE. And afterwards, I will briefly explain how to model erosion in GIS, what you need in terms of data, and then which functions you will need. Please note there's also a hands-on video on how to do this in QGIS. But first of all, let's look at the impact of climate change on soil erosion. There are significant interactions. With climate change, we predict increased precipitation and increased intensity of precipitation. That means extreme rain events. And these rain events will become more frequent and more intense. At the same time, we might see more and more intense droughts and reduced vegetation cover. Both are affecting and increasing erosion. Temperature might also change the soil properties. And last not least, we might see shifts in plant and crop systems. And as I will explain in a couple of minutes, the crop management and the type of crop has an important impact on erosion. Erosion and its modeling is mainly based on the universal soil loss equation, or short USLE, which was developed in the 1960s in the US. Today there are other models too, or there are more advanced, more localized versions of the universal soil loss equation, but the USLE is still the base for most erosion models around the world. The empirically based USLE was originally developed from erosion plot and rainfall simulator experiments. It's plot-based and it's composed of 6 factors which predict the long-term average erosion measured in annual soil loss in tons per hectare. The equation includes the rainfall erosivity factor, R, the soil erodibility factor, K, the 2 topographic factors, L and S, and the crop management factors, C and P. And its simple form is that the annual soil loss equals R multiplied with K, multiplied with L, multiplied with S, C, and P. By the way, that's something you can easily calculate in the raster calculator in QGIS or ArcGIS. Let's have a look at the individual factors one by one. First of all, the rainfall erosivity factor. This one is obviously linked to climate change. And here you could also put in future rainfall erosivity factors depending on your climate change models. In general, it's a factor representing the average rainfall in this. Then second, the soil erodibility factor K is derived from the soil types in the area. Here on the right, you see a typical soil type map for Bavaria. You can get such maps for most parts of the European Union. But that's something you will have to research for your local area. Then, perhaps most interestingly from a GIS factor, we have the topographic factors L and S. L is the length of a slope, and S is the slope itself. L and S can be derived from the digital elevation model. It's an example on the top right in GIS. It's particularly easy in QGIS, and I will show how to do this in a separate video with a hands-on exercise in QGIS. Then we have the crop management factor C. That's depending on the type of crop. For example, corn has a very high factor. Winter rye has a rather small factor. Grass has a rather small factor. Here we can observe a very high impact of this factor. So it really makes a difference what the farmers are growing in these areas. And this could lead to recommendations to perhaps change the crop management. Soil erodibility we already talked about, but here you can also see a map for our example area where we have a very low soil erodibility factor along a river in the southeast of our area and rather high factor with different soil in the northwest of the area. And if you calculate these factors, if you multiply them with each other, you will get the annual average soil erosion in tons per hectare for your area. And this is the final result for our case study. And you can see the flat river floodplains with a different soil and different crop management, mainly grassland. They have almost no erosion. The small red ones are like the drainage canals, but that's not really an issue. In contrast, the agriculturally intensively used areas in the northwest with a lot of corn in hilly terrain, they are susceptible to very high amounts of erosion. Thank you for your attention, and please contact me if you have any further questions.